What is application domain partitioning? Application domain partitioning is the division of a single converged network into separate logical network partitions and quality of service levels in order to isolate the users and devices of each application from other applications and to provide each application with its required quality of service. Using network partitions, inter-application communication can be completely blocked or can be tightly controlled using special inter-application connectivity methods. Application-specific quality of service can ensure that traffic from each application is delivered within its required latency limit and that each application receives its required portion of the overall converged network capacity. A multi-application system should use application domain partitioning to isolate each application to its own network partition. This restricts device access to only the users of the respective applications and isolates the devices of each individual application from the devices of the other application. A multi-application system should also provide differentiated quality of service for each application. These network partitions and quality of service controls are especially important in an IP network since IP does not natively provide security or quality of service. This logical diagram shows application domain partitioning operating over a multi-tier network. Each network tier must have sufficient capacity for all the applications running over its tier, plus the sum of all lower tiers, and latency low enough for the most time-critical application. This may mean that certain networking technologies cannot be used for some network tiers that carry high bandwidth or low latency application traffic. In the diagram, application domain partitions are used to isolate traffic between users and devices of individual smart grid applications and the respective components of the head-end software system. For instance, metering applications and demand-side management can be given their own partitions over the neighborhood area network and wide area network tiers to their respective head-end software applications. Additional services, such as distribution automation, device management, and data acquisition, can be isolated to just their respective applications, which may reside in a different part of the utility head-end. And other services, such as mobile workforce data and remote operating system patching, can be given their own isolated partitions that connect to communication networks, such as the IT network or even the internet. Quality of service is an important aspect of application domain partitioning and is divided into two categories here, rate shaping and traffic prioritization. The left bubble shows rate shaping being used to limit the amount of bandwidth that a single user or device can consume, preserving capacity for other users, devices, and applications. The right bubble shows traffic prioritization, which can be used to ensure latency-sensitive traffic is forwarded with minimal delay. This ensures that applications do not interfere with each other in unintended ways, ensuring that high-priority traffic is not dropped or delayed. For instance, during meter firmware download, data may be sent to millions of meters. Traffic prioritization results in the forwarding of SCADA traffic before the latency-tolerant firmware download traffic. Additionally, rate shaping limits the firmware download traffic to its fair share of the overall network capacity, preserving capacity for the SCADA traffic. Now let's look at how application domain partitioning can address some of the vulnerabilities that we looked at earlier. In the case of an internal breach, such as one user of one application accessing the devices of another application, application domain partitioning can prevent communication through its partitioning of the network into different domains. In this example, the network partition isolates the load-shedding devices in the field from the metering application in the head-end. Even if the user had the credentials, such as a password or a key, needed to control the load-shedding equipment, the network partitioning would prevent them from sending any data to the load-shedding devices. Now let's look at an external breach. A general security principle is to absolutely not let breaches happen, and then to minimize the impact when they do. That is what application domain partitioning is providing in this example. The AMR system should employ an absolutely impenetrable security system. However, security experts will say that impenetrable security doesn't exist. So if a breach were to occur, application domain partitioning will minimize the impact by providing isolation of the application domain. If a meter were to be hacked, such as in the IOActive presentation, application domain partitioning isolates that compromise so that other applications, such as the SCADA systems, are not affected. Now let's look at a malicious attack on the network. In the early example, when a substation was infiltrated, other substations could be attacked over the network. In this scenario, a special case of application domain partitioning that we call intra-application domain partitioning can protect the devices within a single application domain. If one substation was infiltrated, intra-application domain partitioning can prevent other substations from also being compromised from attacks over the network. A special case of network vulnerability that we haven't looked at yet is what happens during fault conditions such as a partial network outage. These are often the times that this network is needed most, so ensuring reliable communications during fault conditions is critical. Specifically, fault conditions increase the need for application quality of service. During faults where traffic is forwarded potentially through alternative paths of the network, some traffic may need to be delayed or even dropped. In this scenario in the diagram, a network fault causes additional traffic to pass through a particular point in the network, which may be carrying a high amount of traffic. With application-based quality of service, traffic prioritization ensures that latency-sensitive traffic is still forwarded with low latency. And if the traffic load is increased beyond the capacity of that point in the network for a sustained period of time, traffic prioritization can ensure that lower priority traffic is dropped and not the high priority traffic. Application domain partitioning is needed on any multi-application converged network that carries application traffic requiring reliable data delivery or low latency. The components of application domain partitioning are not features that can be centralized in a single box. They must be deployed throughout the network. And these components are not meant to replace other security mechanisms. They are needed in addition to the existing and future security mechanisms to provide another level of security and to provide QoS controls. If you'd like more information about application domain partitioning, please download our white paper via the provided link.